5 facts about quantum physics. The universe is a vast and mysterious place, filled with wonders that we are only just beginning to understand. For centuries we thought we had a good grasp on the laws of nature, laws that govern the motion of planets, the behavior of light, the force of gravity. Then came quantum physics. Quantum physics is a branch of science that studies the behavior of matter at the atomic and subatomic level. It is a world where the rules of classical physics no longer apply. A world where particles can be in 2 places at once, where information can travel faster than light, and where the very act of observation can change the outcome of an experiment. Let's start with one of the most mind-boggling concepts in quantum physics, quantum entanglement. Picture this. 2 particles, separated by vast distances, are linked together in such a way that they share the same fate. Imagine flipping a coin. You know that if one coin lands on heads, the other must land on tails. Now imagine these 2 coins were entangled particles. If you measure the state of one particle, you instantly know the state of the other, no matter how far apart they are. It's as if they communicate with each other instantaneously, violating the cosmic speed limit, the speed of light. This spooky action, at a distance, as Einstein called it, has been experimentally confirmed time and again, leaving scientists both baffled and intrigued. This interconnectedness challenges our understanding of space and time, suggesting a deeper, more fundamental level of reality that we are only beginning to grasp. Next we delve into the paradoxical world of wave-particle duality. Imagine a beam of light, a wave of electromagnetic energy, traveling through space. Now imagine that same light behaving like a stream of particles, tiny packets of energy called photons. This is the essence of wave-particle duality, the idea that quantum objects can exhibit both wave-like and particle-like behavior. But how can something be both a wave and a particle? This question has puzzled physicists for decades. It seems counterintuitive, even impossible, but experiments have repeatedly shown that light, electrons, and even atoms can display this dual nature. The famous double-slit experiment, where a single particle can interfere with itself as if it were a wave, demonstrates this concept most vividly. Wave-particle duality forces us to reconsider our classical notions of what it means to be a wave or a particle, blurring the lines between these seemingly distinct categories. Now let's talk about quantum tunneling, a phenomenon that seems like something out of science fiction. Imagine throwing a ball at a wall. In the classical world, the ball would either bounce back, or, if it had enough energy, break through the wall. But in the quantum world, something much stranger can happen. The ball, or rather a subatomic particle, can sometimes pass right through the wall, as if it were a ghost. This is quantum tunneling, the ability of a particle to pass through a potential barrier even if it doesn't have enough energy to do so classically. It's like walking through a wall, something that seems impossible according to the laws of classical physics. Quantum tunneling is not just a theoretical curiosity. It plays a crucial role in many physical phenomena, from nuclear fusion in stars to the operation of transistors in our electronic devices. Hold on tight as we explore the superposition principle, a concept that suggests reality is far more fluid than we perceive. Imagine a quantum object, say an electron, being in multiple states at once, like a spinning coin that is both heads and tails simultaneously. This is the essence of superposition, the idea that a quantum system can exist in multiple states at once until it is measured. Think of Schrödinger's cat, a thought experiment where a cat in a box is both alive and dead until we open the box to observe it. This mind-bending concept suggests that the act of observation plays a fundamental role in shaping reality. It's as if the universe holds multiple possibilities in superposition, and our observation selects one particular outcome, collapsing the wave function. The superposition principle challenges our intuitive understanding of reality, suggesting that what we observe is not necessarily the only possible outcome, but rather one of many potential realities. Finally, we arrive at Heisenberg's uncertainty principle, a fundamental limit on our ability to know both the position and momentum of a particle with perfect accuracy. Imagine trying to pinpoint the exact location and speed of an electron. The more precisely you try to measure its position, the less you know about its momentum, and vice versa. It's as if nature imposes a fundamental limit on our ability to know everything about a particle with absolute certainty. This is not a limitation of our measuring instruments, it's a fundamental property of the quantum world. Heisenberg's uncertainty principle tells us that there is an inherent fuzziness, an intrinsic uncertainty, at the heart of reality. It forces us to abandon the deterministic worldview of classical physics and embrace a reality where chance and probability play a fundamental role. Quantum physics, with its mind-bending concepts, challenges our very understanding of the universe. It reveals a reality that is far stranger, more counterintuitive, and more wondrous than we ever imagined. Quantum entanglement, wave-particle duality, quantum tunneling, superposition, and Heisenberg's uncertainty principle, these are not just abstract theories. They are the fundamental principles that govern the behavior of matter at the most fundamental level. They are the keys to understanding the nature of reality itself. As we delve deeper into the quantum realm, we are constantly pushing the boundaries of human knowledge, venturing into the unknown with curiosity and wonder. The quantum frontier is vast and unexplored, full of mysteries waiting to be unraveled. Who knows what other strange and counterintuitive phenomena await us in the quantum realm? What new insights into the nature of reality will be revealed? The journey of scientific discovery is an endless pursuit, a quest to understand the universe and our place within it.